Good morning, guys. It's Fowler here. So I'm going to give you guys a couple examples on how to do this IXL on trig ratios while rationalizing the denominator. So I'm going to flip this around and we're going to do a couple problems together, and hopefully this helps. If you have any questions, just shoot me an email and I will get back to you as soon as I can. All right, here we go. So here is the first problem we have. This is at a smart score of 50, and as you guys can see, there is a square root of 31, and that is the hypotenuse. We've got the square root of 22, and then 3 for this other side. So in this problem, we're trying to find sine of angle W. So angle W is right here. Sine is, let's see, sine, some old hippie caught another hippie tripping on applesauce. So sine is our opposite over hypotenuse. So if we're looking for sine of angle W, I'll write it down here. That's going to be the opposite over the hypotenuse. So on our picture, W's here, its opposite is 3, and the hypotenuse is the square root of 31. So opposite is 3, hypotenuse is the square root of 31. So now we have a denominator that has a radical, and that is not our standard form. We want to put this in standard form, which means that there is no radical on the bottom. We have to rationalize the denominator. Rationalize it. So we've got 3 root 31. We're going to multiply it by a fraction that is some number over itself, so we're basically timesing it by 1. So to get rid of this radical, we're going to multiply it by the square root of 31 over the square root of 31. Okay? Square root of 31 over square root of 31 equals 1, so it's still going to be the same exact answer. And it will get rid of this radical. So let's do top times top. So we've got 3 times the square root of 31, which is 3 root 31, over, okay, square root of 31 times square root of 31 should just equal 31. Okay, so we have this, and we want to check to see if we can simplify it now. So can we divide 31 and 3 by the same number? Well, 3's factors are 1 and 3, and we cannot divide 31 by 3. So this is going to be our final answer. Sine of W equals 3 root 31 over 31. Okay, so I'm going to type it in here. My little fraction bar. 3 root 31 over 31. Submit. And it says, well done. Okay, now I'm going to jump a level. Okay, so we're looking at a problem that's about a smart score of 68 next. So it wants us to find cosine of angle X. So cosine, caught another hippie. So X is here. So caught another is our adjacent, and we are missing that side, so we're going to have to Pythagorean theorem. And hippie is the hypotenuse. So first things first, we're going to find that adjacent. So we will use Pythagorean theorem. Okay, and so when we're finding a side, not the longest side of the hypotenuse, we're going to take the hypotenuse squared, subtract the other side squared, and that will give us our answer. So down here, I'm just going to write, oops, we're looking for cosine of X, which is adjacent over hypotenuse. Okay, and we have our hypotenuse, which is 3 root 11. And we got to find the adjacent. So our adjacent, 3 root 11 squared minus 3 root 5 squared equals ADJ squared. All right. So when we do this, it'll be 9 times 11, which should be 99, but I'm going to check it in the Desmos. Okay, because I want to make sure I do it right. So 3 root 11. Gonna get out of there. Squared. Yep, 99. So 99 minus this one, it'll be 9 times 5, which should be 45. But again, I'm gonna check it in the Desmos. So 3 root 5. Yep, and it is 45. All right, equals our adjacent squared. So 99 minus 45 should give us 49. No, oh gosh, Fowler fail. No, that's right. $54. Yep. 54. Okay. So our adjacent, because we have to get rid of that square, we're going to square root this. Root 54. And I just want to make sure there's no perfect square factors of 54. So I'm going to look at our factors. Because if we can simplify it, we totally should. And let's see, our perfect square factor, the first one I see is 9. So we can simplify that radical. So remember from a long, long time ago, this equals the square root of 9 times the square root of 6. So our adjacent is 3 root 6. Yup. Yup, yup. So we're going to go back up here. We got our 3 root 6. And that's the adjacent. So let's go ahead and simplify this right here. 3 root 6 over 3 root 11. So before we do anything else, because there's coefficients, we're going to see if they can simplify that. And we can, because 3 over 3 would just cancel out. So we're left with the square root of 6 over the square root of 11. And we want to rationalize that denominator. Okay, so we're going to multiply by a fraction using what's in the bottom of the denominator. So it'd be the square root of 11 over the square root of 11. Okay, top times top, we've got the square root of 66 over bottom times bottom. Square 11 times square 11 is just 11. And so I'm just going to check to make sure that we can't simplify the square root of 66. So I'll type in 66 over x and see if I have any perfect square factors. So let's see, 4 is not a factor. 9 is not a perfect square factor. 16 is not. 25 is not. So no bueno. That's our answer. So up here, I'm going to type it in. Root 66 over 11 and check.